Nitrogen dioxide is an orange-brown gas. This is assumed knowledge for students of many 16 to 18 courses where a change in color over time might be an accepted suggestion for tracking a reaction involving its production or consumption. Today, we're going to make some so that they can see it firsthand and at the same time see a clear demonstration of Avogadro's law. To make my nitrogen dioxide, I'm going to need some nitrogen monoxide and some oxygen. They react in a 2-to-1 ratio to produce 2 moles of nitrogen dioxide. I'm using these 60 centimeter cubed Luer tip syringes and Luer slip 3-way valves for combining these gases. Just like some of my earlier videos based on the work of Bruce Mattson, you can see these probably by the side of me right now, you can avoid the taps, but they do make life easier. I've struggled getting the B-roll footage for today while working in a fume cupboard, so I've done a B-roll for close-up, but I'll also show you how I literally do the reaction myself without needing to focus up close. As always, technician notes and more are available via the EIC website. Start by having at least 5 centimeter cubed of 1.4 molar sulfuric acid handy in a weighing boat or small beaker. I've added some indicator to help it show up on camera better. These vial lids sit snugly inside the syringes. The source of the nitrogen here will be sodium nitrite, although if you don't have this, you can check Bob Worley's channel for an alternative version that uses copper and nitric acid. Without Bob, I never would have discovered Bruce's work in the first place, and working together with Bob helped me realize there was a much simpler, safer way to make the nitrogen monoxide than Bruce originally suggested. Weigh 0.2 grams of sodium nitrite, that's sodium nitrate 3, into a sample vial lid, and then add 1.35 grams of iron sulfate, heptahydrate, on top. When I'm not filming, I weigh directly into the lid, a bit like this. This avoids any errors associated with a small number of crystals not being transferred from a weighing boat. You can lower the vial lid into the syringe by filling it with water and simply floating the cap down. In my B-roll, I've added a little food coloring for visibility. Underneath, there is 0.4 molar sodium hydroxide as a stop bath for later. You'll notice in the clip that I'm wearing gloves. Skin contact with the nitrogen oxide should definitely be avoided, but the main reason for this is that I fell over earlier this week when I was out running, and trust me, nobody would thank me for a close-up of my left hand at the moment. My hands are actually large enough to actually drop the vial lid directly at the bottom of the syringe, so that's how I'm going to do this in front of you right now when I don't need to have a camera inside a fume cupboard. The solids are now in the cap, and they won't react until we dissolve them in something. For this reaction, the something needs to be sulfuric acid because we need hydrogen ions for the redox reaction. When I can angle my body where the camera actually needed to be in the fume cupboard, I can load my liquid a bit like this. It's always better to have more than you need in your small beaker or weighing boat so that you can suck up to the value that you require and you don't get any air inside. I can just simply pop a Luer slip cap over the top, and the solid liquid combo won't react until we invert this. This solid liquid combo isn't the one in the video, so I can show you how I simply rotate, keeping my finger on the cap, and I start to draw back a little bit with the plunger, assisting it as it comes, and I'm making a syringe full of gas. In my B-roll, I've made a syringe of nitrogen monoxide. Here I have a syringe of oxygen because my liquid originally was hydrogen peroxide and the solid was just some potassium iodide that I used to catalyze its decomposition. I wouldn't typically use this technique for making a syringe of oxygen because we have a cylinder available, but this is a great tip for checking out what the concentration is of some peroxide that you diluted last week. I can tell that last week's 20-volt peroxide still is. In the nitrite syringe, iron too is oxidized in the production of the gas, and so a very dark brown liquid is produced in the syringe. We need the gas in a clean, dry syringe. I can pull up my oxygen over to that dry syringe by keeping the wet syringe directly underneath and using a small piece of silicone tubing. I can push from one end, as you can see here, and pulling from the other, transferring the gas as I go. Finally, with a syringe of nitrogen monoxide and a syringe of oxygen, we're ready to combine them. Still working in an efficiently running fume cupboard, squeeze out nitrogen monoxide until you have 40 cm cubed. Squeeze out oxygen until its volume reads 20 cm cubed. From this point on, you can work outside of a fume cupboard. If you just want to show the Avogadro's law element, you can leave this kit set up for the lesson, open the tap, and then go. To avoid leaks, it does help if you pull one syringe as you push the other. Working in hot, bright sunlight today to try and keep my B-roll in focus, I did struggle here, but I've never had an issue working in the open lab. 20 cm cubed and 40 cm cubed of colorless gases combine to give you 40 cm cubed of colored gas. And now you have a tube ready for any lesson on equilibrium. In a couple of months, I'll show you what I do with it. But until then, I'll see you next time.